of motion. Okay. Right, so we just need to define some terms first. This is the full title, Uniformly Accelerated Linear Motion. But often people just say linear motion. So what is this type of motion? Well, firstly, it's movement or motion in a straight line. So that's the linear part. And has a constant acceleration. The acceleration doesn't change, it's constant. That's the uniformly accelerated part. And it's a very common problem in physics. I hope I don't have to tell you what this word is, motion. So, uniformly accelerated is constant acceleration. Linear motion is a straight line. And motion is movement. So it'll be useful to at least write the title down, Uniformly Accelerated Linear Motion. Yeah. Okay, I can continue. I still see some writing. Yeah? Okay. So, this type of problem is very common in physics, and in fact, if you look at the time, sorry, I did it, it was bound to happen, the velocity time graph, it will be a straight line. Okay, so I'm going to give you some formulas which technically could be on the exam, although they've never asked for it. So let's have a look here. So before I start doing my proofs, I'll say it again. These proofs I'm going to show you, they could be on the exam because the syllabus says students need to do this possibly in the exam. Although, of the last 20 exams, it's never been asked. So you should know the proof, and it could come up in the exam, but it's unlikely to come up in the exam. Okay? So let's have a look here. So let's draw our graph. So this is time in seconds, we'll say, and then this is our velocity. Well, I'll write the word time. Time in seconds, and then this is velocity in meters per second, and then we start here with u, and then what do we call the velocity at the end? V. And then here, of course, this is t. Okay. Let's have a look at our formulas. So our first formula doesn't really use the graph. It comes from our triangle. Do you remember this triangle? Well, you know what? I won't do that part yet. I'll just do it straight from the graph. Okay. So let's find a formula for S. So S is the area. So I can break this up into two shapes. Rectangle and then triangle. So the rectangle is UT, and then the triangle is a half T, and what's the height? Nah, gotcha. B minus U. Nearly got you then. So that's UT plus a half. You know what? I'll leave it like that for the moment. Okay, the second formula, or second use of the graph is we know the acceleration is the slope. What's this height here? V minus u. And then what's this base here? T. T, yeah. I can say here AT equals V minus U, or if you want I could say V equals U plus AT. That's actually one of our formulas. This is our first formula. Now what I can do is I can put this formula I just found in here for V. So I get S equals UT plus a half T, and V is U plus AT minus U. Well, what's nice is that they cancel. So then I get S equals UT plus a half AT squared. And that's actually our second formula. Now, what I can do here is I can rearrange this to have T equals V minus U over A, and I can put that in here. So I get S equals, no hang on, wait, something feels wrong. No, actually I think it's okay. I guess we'll find out shortly. Right, so we have U times T, which is V minus U over A, plus a half T, which is V minus U over A, times V minus U. Okay, so if I want to try and keep everything on the screen, if I expand, well, I think I'll multiply everything by A first actually, get rid of those A's.
Half A.
A half A where? Well, this is okay. I think, yeah, this is okay. So I get A.
You put the T value, not the A value.
Huh?
Not the A.
Oh.
Oh yeah, second part. Like
Oh yeah, one of these should be squared, shouldn't it?
Yeah, and this should be A too.
Hang on. Yeah, that doesn't feel right. Yes, I can't skip the formula, I skip at the start. So, on a side note, do you remember this triangle?
Yes.
What's on the top here? What goes here? Remember this triangle? Distance, yeah. And what goes here? Speed. And then what goes here? Time. Yeah. So if I want distance, that's equal to average speed multiply time. So what letter represents distance? S. And what letter represents time? T. Now, what's average speed? So what's the speed at the beginning? U. No, just what's the speed at the beginning? U. And what's the speed at the end? The speed at the end? V. So, if I have two numbers, what's the average of these two numbers? Yeah, U plus V divided by 2. And in fact, this is another one of our formulas. This is called formula 0 actually. So what I can do, I'll take my blue arrow.
About number 2.
It's still, yeah, no, number 2 is still correct. I was just trying to make number 3. In here. Okay, so what would I like to replace? The T still, yeah. S equals U plus V over 2 times T, which is V minus U over A. So you get S equals uv minus u squared plus v squared minus uv all over 2a, and that's nice because that uv and that uv cancels, and I can bring the 2a up here to make it 2af. So I get 2af equals minus u squared plus v squared, or if you want to rewrite it, it's v squared equals u squared plus 2af. Okay. Yeah, so now we have all the formulas I wanted to show you for this lesson. This is formula 3. The reason formula 0 is called formula 0 is because it's not really a new formula, it just comes from the triangle which you learned about really in middle school. It's formulas 1, 2 and 3 that we really care about. That's why they get actual numbers that aren't 0. Okay. Now, the formulas we have S equals U plus V over 2 times T, that was the formula 0. We have V equals U plus AT, S equals UT plus a half AT squared, and V squared equals U squared plus 2AS. So to solve any problem, we need to know at least 3 of the 5 UVATS. So if you know at least 3 of UVATS, you can find the other 2. All I really need you to write down is the name of these, to write down these formulas. That's all I really want you to have right now. So make sure you have those formulas clearly written down in your notebook. Those 4 formulas are very important. Okay. You should have the formulas anyways because I just did the proofs. Right, so here's our first example. A girl is about to start cycling her bicycle. She is at rest and cycles up to 9 meters per second in a time of 6 seconds. Now I don't need you to write down the story. What I want you to write down is the letters, UVATS. No, don't write the words down. So let's read it and you tell me what the UVATS is. So the girl is about to start cycling her bicycle. She is at rest. So what's 0? U is 0. And she cycles to 9 meters per second. V is 9. And the time it took? 6. T is 6. So because you know 3 of the pieces of information, you can find the other 2. So what do we want first? The distance and then the acceleration. So look at the formulas. Which one is the one you need to give you the S?
U plus V plus over 2 times T.
Yeah, S equals U plus V over 2 times T. In fact, maybe we could even do it in our head. So what's the U? 0. And what's the V? 9. 0 plus 9 is 9. Divided by 2? 4.5. Multiplied by 6, what's that? 16, 17, 18? 4.5 times 6. 4 times 6 is 24, 27, yeah. So she travels 27 meters. Okay, so S equals 27. Alright, you calculate the acceleration for me. Now before you do, which formula do you need? Which formula do you need? What do you think? Which one looks like the one that will be useful? I think V equals U plus AT would do it. Here, let me write this down. Okay, so the first one. For the first part, we use S equals U plus V over 2 times T. What was the U? 0. The V? 9, wasn't it?
0 to S. Oh, you did the first one.
Yeah, I'm doing the first one, yeah. 27. Yeah. Okay, and the next part was the acceleration. I can use this formula. 6 equals 0 plus A times 6. Oh, sorry, this is a 9 here, isn't it?
Yeah.
Thank you. 9. So then A equals 9 over 6, 3 over 2, 1.5 meter per second squared. We should really write down what the UV, the information is at the start. U is 0, V is 9, T is 6. Okay, let's have a look at some more now. Can I go on? Okay, so a car is travelling 120 kilometers per hour on the motorway. The driver sees a crash up ahead and suddenly brakes. Okay, so all I want you to do after reading this is tell me the UV ATS. And if you don't know what it is, then we don't know. So do we know the U? 120 kilometers per hour. Do we know the V? 0, good, yeah. Do we know the A? No. Do we know the T? No. Do we know the S? Yeah, 100. So let's write that down. U is 100 kilometers per hour. V is 0. S is 100. What's wrong?
120.
Oh, it said 120, was it? Thank you. 120. Okay. I don't think it should be any problem to convert this now into meters per second. We want to make this meters per second. So let's just do that. Okay. Yeah, I got 33.3 meters per second is its speed. We did conversion in the first lesson, so I'm not going to go through that. Okay, which formula should I use here? Which formula should I use? I need to find both A and T. What do I ask for first, actually? A. So what formula could I use to find A? Is that right? Is that okay? Yeah. What could I use to find A? Which formula? You don't, is everything okay?
Yeah.
What's wrong? Problem? No, okay. What formula can I use to find A? Yeah. I could use this one. Because I know the V, I know the U, I know the S, so I can get the A.
That might be it.
Yeah. So, let's see what happens. I can use V squared equals U squared plus 2AS. 33.3 squared, no, wrong. 0 equals 33.3 squared plus 200A, because it's 2 and an S there. So I got A is minus 5.54 meters per second squared. And the next thing I want is the T. I think I'll use this formula to get the T. It's the easiest one. So I get 0 equals 33.3 minus 5.54 T. So I get T equals 6 seconds. Okay? So it takes 6 seconds for this car to stop.
How do you know that's V equals to 0?
Because the question says the person puts their foot on the brake on the car to stop the car, to bring it to rest. Yeah? Okay. Okay, everybody to try this one for me themselves. So in this question here, you have a ball and it's dropped and it travels 25 meters and it takes 2.26 seconds to hit the ground. So do we know the U? Yeah, we know the U, 0. Do we know the V? No, we don't. We don't know how fast it's going when it hits the ground. Do we know the A? No, we don't. Do we know the T?
Yeah.
We do. And do we know the S?
Yeah.
We do. Okay, so I want everybody to try this for me. Get me the A firstly, and then the V secondly. Now, look there. The U is 0. The V we don't know. The A we don't know. The T is 2.26, isn't it? What's the S? Yeah, I want you to be very careful here. Although it doesn't give you the wrong answer, I think it's a good habit if you say yes is minus 25. Why do I say that? Well, the reason I say that is because we're taking this here as being the origin. So up is positive and down is negative. And remember, F is displacement or position. So this is like, hey look, guys, look. This is like 1, 2, 3 meters, and this is like -1, -2, -3. Now, if you did plus, that's fine, you'll still get the right answer, but I would like you to do it minus. Okay, Grace, what formula should we use? Which formula? Yeah, let's see if she can get it. Now, if you don't know, that's okay. Which formula do you think? Yeah? So you're going, this one, is it? S equals U plus V over 2 times T? Yeah? Let's see, can we do this one? Do I know S?
Yeah.
Yes. Do I know T?
Yeah.
Yeah. Do I know U?
Yeah.
Yeah, so this can give me the V.
Yeah.
Well, that'll do. Okay, so I have minus 25 equals 0 plus V over 2 times 2.26. So, I don't have my calculator. Amanda, can you give me this answer for V?
Yeah.
Yep. Minus?
22.
Give me one number.
1.
1. Why is it minus, Amanda?
Because he is drawn.
Yeah, it's going down. Yeah. Okay. What formula can I use to get the A now? Amanda, actually, what formula can I use to get the A?
V equals U plus A multiplied T.
That's it. Minus 22.1 equals 0 plus A times 2.26. So the A will be minus 9.8 meters per second squared. So we're happy. Okay, next one. Right, so here's Mary dropping her balls in the building. Notice how the distance between each second is increasing. Well, of course it is, because it's getting faster and faster. Notice when the ball is dropped from rest, it will increase its speed by about 10 meters per second each second. So anyway, in my last example, the student dropped the ball off of the building, but it doesn't matter what it is. Whenever you drop something, the acceleration is always 9.81. Okay, so if I drop this and calculate the A, and if I drop this and calculate the A, or if I pick up Fahad and drop Fahad and calculate the A, it's always 9.81. This is called the acceleration due to gravity, and we use the letter G to represent it. 9.81 is what we use for this class. If you studied physics before, maybe use 9.8 or even 10. 9.81. Good. Okay. So please make note of this definition. You don't need to write all of this down. What I really care about is you saying the acceleration due to gravity is g equals 9.81. Really, that's the most important thing here. Okay, continue? Yep. I hear sounds of unhappiness. Is that you, Grace? What's wrong with you? You don't need to write everything. Right. Okay. Right, so this is our last example, and then I'll let you try the questions. So, a ball is thrown vertically upwards at a speed of 50. The ball leaves the girl's hand at a height of 1. The ball travels up and then back down. The girl does not catch the ball and she allows it to hit the ground. So I want to draw what's happening here in this long story. I can do this. There we go. Right. This is 1 meter. So she has a ball, and she throws it straight up, and then it comes straight down and hits here. And the speed at the beginning is 50 meters per second going up. Okay, so what's my first question? Well, no, we'll just go to the first question here. What is the maximum height? Okay, so my first question is, what's the height up here? How high does it go? So let's write down what we know. U, V, A, T, S. Okay. What's the U?
50.
U. 50. The V is 0. Because when it's at its highest, it's not actually moving, and then it falls back down. What's the A?
-9.81.
Yeah, now why is it minus 9.81 and not plus 9.81? Basically, yeah, well basically it's always minus 9.81. But it's especially clear here because when the ball, when the ball goes up in the air, is it going faster or slower? Slower, so it's decelerating, so it has to be minus. Okay, do we know the T? No. And do we know the X? No. That's actually what we want. Yeah, so what formula can I use to get the S here? Not this one because I don't know the T. Oh, well, which one? S equals maybe UT plus a half AT squared? Maybe not this one. What about V squared equals U squared plus 2AS? I get 0 equals 50 squared plus 2AS. So, can I set the calculator there perhaps? Or maybe actually I put one in my bag today. Hey, I did. 50 squared divided by 2 times, no particular one. So you get 127.4 meters as part A. Is that right?
4 and minus.
No, I took out, everything's okay here, plus and the minus. Is that right? Is it? No, it's not right. I'm missing one thing. I forgot to do one thing to my answer. I must do plus 1. Because here is what's in the formula being used as the origin. So the answer you got was actually this answer here. That's why I have to add the 1 here. Because the ball is actually starting 1 meter above the ground. It's not actually starting off the ground. So the answer is 128.4. Okay, what's next? How long until it hits the ground? How far does the ball travel? How fast the ball go and when it hits the ground? Okay, how long until the ball... What is it? How long until the ball hits the ground? Okay, now I want to know how long until it hits the ground. Whoops. What's the U? Well, that's still 50. What's the V? I don't know. What's the A? Minus 9.81. What's the T? Don't know, that's what I want. And what's the F? Minus 1. Because I want to know how long until the ball goes from here to here. 1 meter below where it started. I think if we look at this horizontally, it's not as difficult. If it starts here and goes over to here and then back, this is like x equals minus 1 meter. That's what I want. When is it 1 meter below where I start? It's the same here, just vertically. So the x is minus 1. Now this is the type of thing which people get wrong in the exam. Remember, x is where the ball is. So we want it to be 1 meter below the starting point. X equals minus 1. Yeah? Does that make sense? Why x equals minus 1? I feel unhappiness. So what's the question? If you have the question, I promise you someone else is thinking that question also. Yeah, good question. Okay, so this is the origin. Look. So here my pen is S equals 10 centimeters. Yeah? And then S equals 20, S equals 30. S equals 20, S equals 10. What about here? S equals 0. What about here? Minus 10. So what I want is the ball to go up and down. So remember, the S is where the ball is at the end. So at the end you want the ball to be minus 1. Yeah, because we take our hand as being 0.
Hand 0.
Our hand is 0.
Origin.
Yeah, the origin. Yeah, not the ground. We take the origin as where it started. Yeah? That seems a bit better. Okay, so I want the T and the V to finish this question. So what formula will I use? What formula will I use here? Let me see. Could I use V squared equals S? V squared equals U squared plus 2AS. Yeah, I could use that. V squared equals U squared plus 2AS, which equals 50 squared plus 2AS is minus 1. So that means V squared equals 50 squared plus 2 times 9.81, which is 2519.62 meters. So V equals 50.2 meters per second about. And then lastly, I think we want the T. So I can use V equals U plus AT. 50.2 equals 50 plus AT. That seems really small for the time. Oh! I forgot one thing right here. Can anybody tell me? Yeah, what did I forget here? When I take a square root, I have plus or minus. Which is the correct one? No. Why? Why? It's going down, yeah, so actually I should have put my b here as minus. Minus 50.2 minus 50 divided by minus 9.81. So now I shall get t equals 10.2 seconds. Have I answered everything in that now?
Yeah.
Was the last thing the time, was it?
Yeah.
Or how fast and how... Oh no, the last thing is how far does the ball travel? Well, actually you don't need any special maths to work out how far the ball travels. The distance would equal... what was this distance here? 127.4 plus 127.4 plus 1. That's the total distance it travels. 127.4 plus 127.4 plus 1. So it travels 255.8 meters. That's the distance it traveled. Up, down and under, yes. So notice at the end, what's the x? At the end, what's the x for the ball? Minus 1 meter. But the distance isn't minus 1. The distance is 255.8. So please notice in this example the big difference between the x and the distance. They're very different here.
The x is the distance?
Yes. And that is the true distance. Yeah. This question I just did for you here, this would be, a section A question for 5 marks. A typical section A question.
So 5 marks?
5%. Yeah.
5 marks or 5%?
Same thing. It's a 100-mark exam.
Oh, okay.
Yeah. Okay. Right. So if you need to, you can take a picture of this, okay? And then what I would like you to do is, I want everybody to do the first one now. And then once number 1 is done, we'll do the next lesson, okay?